So today, this is Professor Vargas. Today we're doing experiment 11, solutions. What exactly is a solution? Well, as you guys probably know, a solution is some sort of mixture, liquid mixture of some sort that has stuff dissolved in it, right? For example, mouthwash is a solution. Okay, so it says here a solution is a homogeneous mixture. Homogeneous meaning the composition is the same throughout, right? Homogeneous mixture. So every time you make Kool-Aid at home, for example, you form a solution. The powder mix is your solute, is referred to as your solute, and the water is the solvent. Every time you make coffee, for example, you add the coffee to the hot water. The coffee is going to be the solute, and the hot water is going to be the solvent. So how do you know what's what, right? Well, it's very simple. For a solute is always present in least quantity. A solvent is present in greater quantity. That's why when you make Kool-Aid at home, the powder mix being in lesser quantity is your solute, and the solvent is the water in greater quantity. Okay. So a solution is always composed of two components, two different components, solute and solvent. Now, in this experiment, we're going to learn how to prepare a solution. We're going to prepare a solution of salt, aqueous solution of salt, and we're going to calculate its concentration. Now, there's many ways of calculating the concentration of a solution. One typical way, one very common way, is to calculate what's called molarity. And molarity here given by equation number 1. The symbol for molarity is capital M. And molarity is moles of solute over liters of solution. Please pay attention to this. This is solution, not solvent. You must remember that solution equals the solute plus the solvent. Okay? So it's moles of solute over liters of solution. This is the way we calculate concentration. In this case, molarity. This is the way we calculate molarity, okay? So, this experiment, there's two parts, and let's focus on part 1, which is we want to prepare 100 milliliters of a 0.69 molar NaCl solution. So this is going to be our desired quantity. Desired concentration, desired molarity. This is going to be our desired volume. So the first thing we need to figure out is how much salt are we going to need, right? We're going to prepare a solution of salt dissolved in water. How much salt do we need to weigh out on the scale? So the first thing you want to do is maybe take the volume and multiply it by the molarity. Volume times molarity. If you take the volume times the molarity, what you're going to end up with here, you're going to end up with moles. Moles of NaCl in this case. So again, what's their desired volume? Our desired volume is 100 milliliters, but we need to convert the volume to liters. The molarity is 0.69 molar. What is molarity again? That's moles over liters. What do you get here when you multiply the volume, which is liters, times the molarity, which is moles over liters? Well, liters go away, and you live with moles. Okay, so this is the first thing you're going to do when you do your calculations for this experiment. However, you guys know that when you're in the lab, the scales that we use, we have to work with grams, a unit of mass. So once you have the moles, you must convert to grams. And you do that by working with the molar mass. In this case, the molar mass of salt. Okay, so be clear that we want to prepare 100 milliliters of a 0.69 molar NaCl solution. Our solvent is going to be water. It's going to be an aqueous solution. First, you need to find the moles of salt by doing this. And once you find the moles, you convert to grams by doing this. Okay? So I'm going to list all the steps here that we need to take in order to form a solution. And then on the video clip, I'm going to show you all the steps. So the first thing you have to do is calculate the amount of salt in grams. Once we do that, we're going to place our salt into what's called a volumetric flask. Okay, so a volumetric flask. Here's a drawing of a volumetric flask, and I'm going to show you that in the video. So these are the steps that I'm going to take in preparing a solution. You guys will see this in the video. So we're going to calculate how much salt we need. That's number one. We're going to, I'm going to add the salt to the volumetric flask. I'm going to add some distilled water. I'm going to swirl it. And then I'm going to add distilled water to the mark here. And I'm going to invert the flask 2 times and then label the flask. So the volumetric flask has a mark there. And we want to make sure that if it's a 100 millimeter volumetric flask, let's say this is a 100 milliliter volumetric flask, we want to make sure the meniscus is touching the mark. Okay, if you go past the mark, you cannot simply pour some of it out to fix it. You're going to have to start all over. Okay, so I'm going to show you how to do this in the video. Okay, so here you're going to do your calculations. Like I showed you, here's the steps you need to take. What you write here, it's also going to be here. We're going to pretend that what you actually calculated is exactly what you measured in the scale. And then the whole point of this for part 1, part A, is to do the molarity, calculate the molarity, okay? So once you have the moles, you can, and the volume, you can calculate the molarity of the solution. So now let's watch the video. Okay, so the whole task here for the first part of experiment number 11 is to prepare a 100 milliliter solution of salt, right? So this is what a volumetric flask looks like. This happens to be 100 milliliters because that's what we want. That we want our final volume, our total volume, to be 100 milliliters. That's how much we need. And this is the amount that you guys are supposed to calculate. How much of salt are you supposed to weigh on the scale? So I went ahead and got some salt here. So what I'm going to do, I'm going to fold the weighing paper and I'm going to place the salt inside the volumetric flask. So I'm just going to weigh the weighing paper like this, and I'm going to place it in here. So now I'm going to take some distilled water here, and I'm going to add some distilled water to make sure that I dissolve all of the salt that I added. Now, I'm not going to fill the flask with distilled water yet, not yet. First, we want to make sure that all the salt dissolves before we do that. So these are the steps that you would take whenever you want to prepare a solution. So I've dissolved all of the salt now. So now the volumetric flask has a mark here. The mark is hard to see, but the mark is right here. And I want to add some water, but once I get close to the mark, I'm going to use my medicine dropper to add water drop by drop. So here I have some distilled water in the speaker, and I'm going to add some water to it. Okay, so I've added some distilled water now, but I still have to add some more water so the meniscus is touching the mark. So I'm going to use the medicine dropper here to do that. Now I want to make sure I'm at eye level with the mark. Okay, so the meniscus is touching the mark now. So now there's one last thing to do here. Using both hands, I'm going to invert it twice. And here we have a 0.69 molar sodium chloride solutions. 0.69 molar aqueous sodium chloride solution. Okay, so now we're going to do part 2 of experiment number 11. And for part 2, we need to take a concentrated solution, referred to as a stock solution. Take some of that stock solution out and place it into a volumetric flask and then dilute it with water so that we have a less concentrated solution. So for part 2 of experiment number 11, we're going to do what's called a dilution. So our stock is going to be 4 molar salt solution. And we need to figure out how much of the 4 molar salt solution do we need to remove so that we can place it into a 250 millimeter volumetric flask. So we're going to remove some of this and place it inside. The question is, how much do we remove? Well, that depends on our concentration. We want to make 250 milliliters, and we want our concentration to be 0.350 molar. So this right here is our desired concentration. This right here represents our total volume that we want, that we desire. Okay. So how much of the stock solution are we going to remove? Place it in here. And then we're going to dilute it with water. We're going to add water, distilled water, so that we have our new solution. That's going to be 0.350 molar salt. This is the intention behind part 2 of experiment number 11. Okay, now, in order to determine how much of the stock we need to remove, we need to use this equation here. Okay, M1 is our initial molarity, or our concentrated molarity, so this is our initial molarity. V1 is our initial volume. M2 is going to be our final molarity. And V2 is going to be our final volume, or total volume. So here, this right here, the 250 millimeters, what do you guys think that is? Is that V1 or V2? Well, we want a total final volume of 250 millimeters, so that's going to be our V2. This right here is going to be our M2, our final concentration, final molarity. The 4 molar stock, that's going to be our initial molarity. So we need to solve for V1. So V1, if you were to rearrange this equation, you would solve for V1, and V1 is equal to this. So you have M2, you have V2, and you have M1. You just plug it in, and you're going to determine how much milliliters. You can work in milliliters. There is no need for you to convert to liters. How many millimeters do you need to remove from the stock solution? Place it into our 250 volumetric flask, and then add water to the mark, so that we have our new concentration of 0.350 molar NaCl. That's what we're going to do for this experiment. So what you guys have to do, you guys have to calculate V1. Okay. And that's going to go there. And then on the video clip, I'll show you the steps that we need to take. Okay, so this is part 2 for experiment number 11. This is a 250 millimeter volumetric flask. It's quite large. So here we have our stock solution. It's a 4 molar aqueous NaCl solution, sodium chloride solution. And what you guys need to do is calculate how much of this stuff do we need to remove and place it into our 250 millimeter volumetric flask. Once we do that, we're going to dilute it with water to form our desired concentrated solution. So the first thing we have to do here is use what's called a pipette filler and also a volumetric pipette. Okay, so normally you're supposed to rinse this twice with water, and also you're supposed to rinse it with the solution as well. So here I pour some stock solution into this beaker, and I'm going to rinse the pipette by withdrawing some of the liquid out. So all I'm going to do here is rotate this, and as you can see, I'm withdrawing some liquid inside already. So what I'm going to do now, I'm going to remove the pipette filler, and I'm going to go ahead and make sure that I rinse the inside of the pipette here by doing this. And then here, this is going to act as my waste container, and I'm going to let it pour into the waste container. So normally you're supposed to do this at least 2 times. So now I can attach the pipette filler here, and now I'm ready to withdraw the liquid that I need. So this is not the right size volumetric pipette, but you always want to use one of these when you're transferring liquids from one solution to another solution. You are not allowed to use a graduated cylinder. I mean, you can, but normally we don't use graduated cylinders for this purpose. So you're going to obtain the amount that you need. You might have to use the pipette more than once. And this is going to go in there like this. Okay, so I transferred the amount that you guys calculated. Let's assume that. And the next thing we want to do now, I want to add some distilled water. So next, we're going to do this. We want to make sure everything is dissolved. And now we can fill it up with some distilled water. Okay, so I added some water and it's close to the mark. So the mark is all the way here, about there. At this point, I want to switch to using a medicine dropper. And I want to add drop by drop like this. Now it's very important you're actually at eye level so you can see where the meniscus touches the mark. And just like that, we've prepared a 0.350 molar NaCl solution, aqueous solution. Okay, so to summarize, I took some of the stock. Using a volumetric pipette and pipette filler, I transferred some of the stock into there. I added some distilled water, I swirl it, and then I fill it with some distilled water. To make sure the meniscus touches the mark, I use a medicine dropper, and then I invert it and I label the flask. And there you go. Okay, so experiment 11, please note there's a pre-lab and there's also a post-lab. Please submit everything together. Thank you.